Hello, Algebra 2 classes. While I still have your attention before we get into our final lesson of the year, I just wanted to say thank you again and tell you how much I enjoyed working with you guys. Both my Algebra 2 classes were just full of very nice students, diligent workers, and I really enjoyed working with you in class. And I very much appreciate the work that you've done during distance learning as well. Distance learning, planning these lessons and doing this instruction is something that really could have been very difficult for me, and you guys helped to make it as easy as possible for me because you stayed up to date with the work, you contacted me with questions, you kept in touch with me, and I really appreciate both the work you did in class in the first 3 marking periods and the work you've done during distance learning. I miss you guys, and I really am glad that I'll get to see you in the fall, whether it's in the hallways or if I'm lucky enough in my classroom again. So that's the first thing I wanted to say. Next, for anyone who might be wondering, because we did distance learning and it was so different than we would do in school, you might be wondering if we covered everything we're supposed to. We did. So for this Algebra 2 class, we covered every topic we normally cover. There's one extra topic that a couple Algebra 2 classes were able to fit in. It's called matrices, but it's something that some teachers fit it in, some teachers don't, and it varies from year to year. So we covered everything you need to be successful in pre-calculus and beyond. Today's lesson is going to be a review of quadratic functions. So we're going to be graphing parabolas that are in vertex form or standard form. And through that review, we're going to review how to find x-intercepts and y-intercepts. We're going to review the quadratic formula, solving using the square root method. And so there's a lot to review in there. And as I started preparing today's lesson, I realized that I already had this lesson ready because I taught this same lesson to my Precalc Enriched this year. In Precalc Enriched, typically we teach all the new stuff at the beginning, and then we save the last marking period to review quadratics, polynomials, and logarithms. That should sound familiar. So we put all that review usually at the end of the year for Precalc, just to make their lives a little easier, especially for the seniors, because you'll see when you're a senior, it's hard to stay focused in late spring. So your review lesson today is actually part of a Precalc lesson that I did this year. So I thought that would be kind of good to see, because then you get a feel for the pace that we would go through a review topic in Precalc Enriched. Please rest assured, for any new material next year, we definitely take it slower and we go through more examples. But since this is a review from Algebra 1 and Algebra 2, as you watch the lesson, you'll see what it's like. So please do print the handout and please do take notes today. And I'll see you at the end of the lesson. Section 2.1 is quadratic functions. And a quadratic function is a graph whose shape is a parabola, and that parabola opens up or down. And just so you know, parabolas themselves can actually open sideways. They can have an axis of symmetry that's horizontal. They can even open on a diagonal. They can have an axis of symmetry that's oblique. But the only ones that we're going to deal with right now are the ones that open up or down. So all of these are parabolas, including these. But only these are quadratic functions, the one that's open up or down, because this fails the vertical line test. Here's a vertical line that hits the graph twice. That's not a function. This one fails the vertical line test as well. Not a function. So quadratic functions are parabolas that open up or down, because only those kind of parabolas, the ones that open up or down, pass the vertical line test. So, so this you're already aware of. Just to remind you, graphs can have 0, 1, or 2 x-intercepts. Go ahead and throw the arrows. If you printed the worksheet, go ahead and throw the arrows on the ends of each of those parabolas, because the graph doesn't just stop there. The graph continues up forever to the left, up forever to the right. And just as a quick reminder, your graphs can have no x-intercepts, 1 or 2. Most have 2 x-intercepts, but if the vertex is on the x-axis, you'll have 1 x-intercept, like this one, like this one. And some graphs have no x-intercepts. So this one, it opens up and it's above the x-axis, so it never touches the x-axis, and it has no x-intercepts. All of these graphs of quadratic functions, however, must have exactly 1 y-intercept. So here's the y-intercept, here's the y-intercept, and this one looks like it doesn't have a y-intercept, but it does, just not in this viewing window. If we extend the y-axis and we extend this graph, eventually we're going to cross the y-axis. So you're always going to have exactly 1 y-intercept. And just to kind of remind you, because the domain for each of these is all real numbers, they go forever to the left and forever to the right, eventually you have to cross the y-axis. And you certainly can't have more than one y-intercept, because no matter what your graph looks like, if you have 2 points on the y-axis, you'd fail the vertical line test. So all of the graphs for quadratic functions will have exactly one y-intercept. There are two formats for the equation of a quadratic function that we're going to review in today's lesson, and they are definition form, which is when you have y equals ax squared plus bx plus c. Our textbook calls that the definition. Your textbook last year called it standard form. So depending on the textbook, you'll see either one of those labels. And then we also have this one down here that is often called transformation form, vertex form, or in your textbook this year, it's actually called standard form. So standard form can be kind of confusing because in last year's Algebra 2 book, this was standard form. In the Precalc book, they call this standard form. So I tried to avoid that label this year because I don't want to confuse you. So we'll call this the definition, and this we'll either call transformation or vertex form. And we're going to review both of these. So let's start with definition form. You should be aware of all of these facts from your work in Algebra 1 and Algebra 2. And this part might look a little tricky to you. It's how to find the vertex. The vertex is you use negative b over 2a to find the x coordinate. And this is the y coordinate. To find the y coordinate, all this says is f of negative b over 2a. So whatever you get for the x, you just plug it into the function f. That's all that means, and we'll see that in action in a moment. When you have this definition form, the y-intercept is always going to be c. And to find the x-intercepts, you want to try factoring. If factoring doesn't work, quadratic formula. So let's go ahead and do our first example together. We are going to determine all of these things right here. And we don't have to do them in that order. We can do that in any order we want. So what I would do first is how it opens is actually pretty quick. So here your a is 1, your b is 4, and your c is negative 6, because a is the coefficient of x squared. And since a is positive, the parabola opens up. I don't think you even have to write down any work for that. I think you can just write down opens up, but if you want that little refresher, if you don't remember your facts about quadratic functions right off the bat, you might want to write that down. Okay, so we know how it opens. Let's go ahead and find the vertex next. So to find the vertex, when you are in this definition form, you have to do work. You can't tell just by looking. So for the work, we start with negative b over 2a. That gives you the x coordinate of the vertex. So in this case, b is 4, so it's going to be negative 4 over 2 times 1. And that's going to come out to negative 2. That's the x coordinate of the vertex. To find the y coordinate, we need to plug this into the function. So I want to find f of negative 2. And when I go to find f of negative 2, I'm going to end up with negative 10 as my answer. So first we're going to square negative 2. And we end up with negative 10. So that is the location of our vertex. And again, there's no way to tell that just by looking when you're in this definition form. All right. I like to, when I find the vertex, find the axis of symmetry next, because the axis of symmetry is going to be the vertical line that goes right through the x coordinate of the vertex. So that's why for the axis of symmetry up here, it says x equals negative b over 2a. It's the same formula because the axis of symmetry always is the vertical line. So you can write that down if you want. It's the vertical line that goes through the x coordinate of the vertex. So that's going to be our axis of symmetry. And now we need to find the intercepts. So we need to find x-intercepts if there are any, and the y-intercept. I'm going to do y-intercept first because the y-intercept is really easy to find when you're in this format. For the y-intercept, it's 0c whenever you're in this definition form. So the y-intercept for this one is 0, negative 6. And there's no work to do on that. You can just tell by looking at what the constant is when you're in definition form. And if you forget that you can figure that out without doing any work, you can always do the work or think about the work. To find a y-intercept, the way that we can do that with any function is to set x equal to 0. So if you think about going up here and plugging in 0 for x, you'll have 0 squared, which is 0, plus 4 times 0, which is 0, which leaves you with -6. So that's why it's always just comes out to c for the definition form. And then for the x-intercepts, we have some work to do. So for the x-intercepts, we want to set y equal to 0. And we would try to factor, but this does not factor. So we're going to use the quadratic formula instead. So the quadratic formula is something you're expected to know and remember from Algebra 1 and Algebra 2. So in this case, it's going to be opposite of 4 plus or minus. B squared is going to be 16 minus 4 times 1 times -6 all over 2a. And watch out for those signs inside the radicand here, because if you make a sign error in here, you might think you have imaginary zeros when you have real zeros or vice versa. So I have 16, and this is going to become a plus 24. You want to be very careful with that, because if you write minus 24, you'd have an imaginary number, which can happen, but it doesn't happen in this problem. So what I have is -4 plus or minus radical 40 over 2. And now we need to simplify that expression. So we're going to simplify the square root of 40. Square root of 40 is 2 radical 10. And then we need to pull this apart in order to simplify all the way. So what we're going to do is take -4 over 2 plus or minus 2 radical 10 over 2. And that is going to simplify to -2 plus or minus radical 10, because -4 over 2 simplifies to -2. And the 2 radical 10 over 2, those 2's are going to reduce and leave us with just radical 10. So these are our x-intercepts. So in exact form, it would be -2 plus radical 10, 0, and -2 minus radical 10, 0. Now, if we're going to look to graph this, because the directions said to graph, we're going to need to know what those values are. So what we're going to do is we're going to sneak a calculator for some decimal approximations. And when we do that, we're going to end up with about 1.16 for a decimal approximation on that. And the decimal approximation on this one is about -5.16 when we sneak a calculator. And we'll need those decimal approximations in order to make the graph. So now we found all of our important characteristics to help us make a graph. And what we're going to do is plan out that graph. So thinking about all the characteristics we have here, I didn't provide you with graph paper because I wanted you to actually think about the graph here. So thinking about the graph, when we go to set up our x-axis and our y-axis, we want to think about whether we want to use a scale of 1 or a scale of 2 or a scale of 10. And we want to think about how far out to the left and how far out to the right and how far up and down we need to see. So looking at these important characteristics here, what's the furthest left we need on the x-axis? It's -5.16. So the furthest left I need to go is -5, and the furthest to the right I need to go is about 1.16. So I feel comfortable counting by ones. I don't think we need to make a scale that is by 2 or by 3 or anything like that. So I'm going to estimate 1.16, and I'm going to estimate -5.16. Now for the y-axis, we want to think about how high or how high up and how far down we need to go. So looking at these important characteristics, what is the lowest y value we need on this graph? It's the -10. So for my graph here, counting by ones may not fit very well. So we might want to count by 2's or count by 5's. I'm going to count by 2's. 2, 4, 6, 8, and that makes this -10. So -2, -10 will be here. For my vertex, my y-intercept is -6. And my axis of symmetry is x equals -2. If we draw in the axis of symmetry, we draw it in as a dashed vertical line because it's not technically part of the graph. it shows us the symmetry of the graph. Because now when we make that nice U-shaped curve, connecting the dots, this axis of symmetry should be a line where if we were to fold along that line, these two sides match up with each other. Of course, mine's not going to be perfect, and I don't expect yours to be either, but that's pretty good. You do not have to draw in the axis of symmetry. The directions said to find the equation, so make sure you do that, but you don't have to include it in your sketch. So if you don't feel like you need it, then you don't have to include it. And that's our first example. So a couple things just to reiterate. The y-intercept you can get immediately just by looking at the graph for the equation. Sorry. For the vertex, you need to do work. When you find x-intercepts, you want to try to factor if you have definition form. If you can't factor, do quadratic formula. Do simplify those answers. And if you have radicals in your answers, sneak a calculator to get the decimal approximations. One more thing to note here. If you get imaginary zeros, they are not x-intercepts. So when you're finding those x-intercepts, if you get imaginary zeros, they are not x-intercepts. The graph does not have x-intercepts. So if we were working on this problem and we ended up with an I here because we had like a negative inside the radical, we wouldn't even have to simplify it. We can just stop and say, oh, there are no x-intercepts for that graph. Okay, and I don't think we need to do another full example to do that. I think I'll make sure you get to practice one of those on your own. So that's definition form. Let's go ahead and move into transformation or vertex form. In your book, it's called standard form, but that's not a very typical name for this form. So this is where we can identify an H and a K. So you'll see parentheses and you'll see a quantity squared. And you know that this information, you know all about the vertex. For the H, you take the opposite sign. That's why there's a minus in the formula. And K, you keep the sign. And you have to do work to solve for the x-intercept. And to find x-intercepts, I'm going to suggest the square root method. So same instructions as the last one. And here's an example for us to try. And I chose to write y equals this time. I totally could have put f of x or g of x. So taking a look, again, we can do this in any order we want. I'm going to do how the parabola opens first. This parabola opens down. The a value here is -2. And since a is negative, the parabola opens down. So that means no matter what this looks like, the vertex is going to be a maximum. When you have a parabola that opens up, your vertex is a min. But since this one opens down, your vertex is going to be a maximum. It's going to be a high point on the graph. Next, I'm going to go ahead and do the vertex. When you are in this vertex or transformation form, your vertex is just HK. You can find that without doing any work. So you look at this number that's being added or subtracted inside, you take the opposite sign of what you see. So we're going to do a 4, and then the number that's outside, you keep the sign. So I think you remember that from Algebra 1 and Algebra 2, but just to remind you, opposite sign, keep sign. And another way to think of this, by the way, the reason it's also called transformation form is you know your transformations. This is a vertical stretch of x squared. This is reflection over the x-axis. This is a horizontal shift. Which way does the -4 move your graph, left or right? It moves it 4 to the right. So if you think about a basic parabola, yes, we're going to do a vertical stretch. We're going to flip it over the x-axis. But if the vertex is usually at 0, 0, if we're going to move it 4 to the right, doesn't it make sense that the x-coordinate becomes 4? And then this moves the graph up 18. So if I move it 4 to the right and up 18, then my vertex should change from 0, 0 to 4, 18. So you can get the vertex by using transformations or by thinking about H and K, changing the sign, keeping the sign. It's all the same. And then for your axis of symmetry, the axis of symmetry is always the vertical line that goes right through the vertex. So the vertical line that goes right through the vertex is going to be x equals 4. And you can write that down in words if you want right here. Axis of symmetry is always the vertical line that goes through the x coordinate of the vertex. That's why whenever I find the vertex, I usually do the axis of symmetry right away. For the y-intercept, you must do the work. When you are in this vertex or transformation form, sometimes people mistakenly think that the y-intercept is going to be this, because when you're in the definition form, the y-intercept is the number by itself. But that's because if you plug in 0 here and here, everything else cancels. So that's why you can do the y-intercept without looking or doing any work. But in this format, this is not the y-intercept. You must do the work to find the y-intercept. So what you want to do is set x equal to 0. That's how we find any y-intercept. So if we set x equal to 0 and then do PEMDAS, inside the parentheses we'll have -4. And then by order of operations, we'll do exponents next. And then we'll multiply. And then we'll do our addition and subtraction. And what we're going to get here is -14. So by setting x equal to 0, we'll get our y-intercept as -14, which is not this number. You must do the work when you're in vertex or transformation form. And now we want to find the x-intercepts, if there are any. Remember, for x-intercepts, there might be 1, there might be none, there might be 2. So to find x-intercepts, I recommend square root method. So what that is when you go and put y equal to 0, instead of doing x minus 4 squared and foiling that and distributing to -2 and then trying to factor or trying to do quadratic formula, I would do square root method. You want to isolate this quantity that's squared. So we're going to move 18 to the other side. We're going to move 2 to the other side by dividing it. And then when you do the square root of both sides, don't forget the plus or minus. So when you take the square root of 9, you get plus or minus square root 9. The square root on this side is going to cancel out the squared. In this case, there's a perfect square inside the radical. That doesn't always happen. The radicand right here could be negative. If it's negative, then your zeros are imaginary. And you can stop because there are no x-intercepts. If this number were positive but not a perfect square, so if you had like a 10 in here or like a 15 or something, then your answers would have a radical, and that's okay. For this particular example, I made it up so that you would end up with a perfect square radicand, which means your radical goes away. And now to finish solving for x, let me switch the two sides. When we solve for x, we're going to add 4 to the other side. This gives us 2 answers. What are those 2 answers? It is not 7 and -7. 7 is one of the answers, -7 is not the other. Because when you write this out, you'll have 3 plus 4, and sure enough, that's 7. But this one is -3 plus 4, which is not -7, it's +1. And I wanted to mention that because a very common mistake people make is they assume that the whole thing gets a plus or minus. That's not the case. It's only the 3 that changes signs here, not the 4. So your 2 x-intercepts are 7, 0, and 1, 0. And again, just to remind you, if you had ended up with an imaginary number in here, you don't even have to finish simplifying. You can stop and say no x-intercepts. If you end up with a radical in this answer, so right here, you could have a radical right there. Instead of a 3, you could have like a radical, like let's say plus or minus radical 2 plus 10 or something. That can happen. You would sneak a calculator and get some decimal approximations. But as it turns out, we have very nice numbers in this one. So we are ready to graph because we did everything we were supposed to do. So let's think about our graph for a moment when we go to set up our axes. Think of all these important points and characteristics. What is the furthest left our graph needs to go? 1. And the furthest to the right, because this is in between. See, this furthest left is 1 and the furthest right is 7. That's in between. So the furthest left is 1, the furthest right is 7. So when I go to set up my graph, I really don't need anything to the left of the y-axis because there's really no part of the graph that's going to go over there. Now think about the highest point on the graph. And the highest point on the graph has to go all the way up to 18. That's the highest y value. And the lowest y value is -14. So even though on the x-axis, I don't need very much to the left or right, I can probably just count by ones. On the y-axis, I really need to go pretty high up, all the way up to 18. And on the y-axis, I need to go all the way down to -14. So for the graph that I have, I don't even think I can use a scale of 2. I might need to use a scale of 3 or a scale of 5. So depending on how much space you have, you could count by 2s. You could even count by 1s, but that's a lot of tick marks. I'm going to count by 3s. So here's 3, 6, 9, 12, 15, 18. I barely fit that. 4. Okay, there's my vertex at 418. And remember, this opens down, as we discovered before, so it makes sense that the point is up here, and we're going to have a U that opens down. It's going to fit together nicely. And then to do -14, if I'm going to count by 3s on this part of the y-axis, I have to count by 3s here. I can't count by 2s. Okay, so you can count by different numbers on the x-axis. On the x-axis, I'm counting by 1s. On the y-axis, I'm counting by 3s. But on different axes, you can count by different numbers. But within the one axis, you have to be consistent. So you can't count by 3s up here and then count by 2s down here. So this is -3, 6, 9, 12, -15. So I'll have to estimate my y-intercept at -14 right there. And then I'm going to make a U-shaped curve that opens down. And depending on what you used for your scale, if you used a scale of 5, your graph might look a little different than mine. It might look narrower, it might look wider. If you used a scale of 1 on the y-axis, your graph might look narrower than mine, and that's okay. But do try to make sure it's a U shape. You don't want a point up here at the top. So if you find that your graph looks kind of pointy at the top, go in and fix it, please. Go in and round it out. This is a U-shaped curve when you have a parabola. And if you want to draw on the axis of symmetry, just make it a dashed vertical line, and it should look like the two sides match up perfectly. Of course, mine is not that good, but pretty good. It's as good as it's going to get for what we're doing right now. So that is transformation or vertex form. And again, I don't think I have to walk you through another one. I think you'll be able to do the practice on this on your own since you've been doing this since Algebra 1 class. All right, guys, thanks for watching. That was your last Algebra 2 lesson of the year. I hope you have a great summer, and I'll see you in the fall. Bye.